Hello, class 12 students. Welcome once again to Math is Possible. In the last video, we had done till question number 18, and question number 18 had 3 parts, and I have done all 3 parts. So today we are going to do with question number 19, 20, and 21. Okay, just get your books out quickly, and you can start looking, and then after that copy. So the question number 19 is this: minus a square. AB, then AC, then AB, and minus B square, then BC, then AC, then BC, and minus C square. You have to prove is equal to 4A square, B square, and C square. Now look very carefully. Okay, I hope I have copied everything correctly, because I make a mistake in copying. CBC and minus C square. Okay, now look very carefully. From what we can do from here is, if we take out the A from this first row, if we take out the B from the second row, if we take out the C from this third row, at least we are getting some part of it, right? We are getting an A, B, C out. We are getting A, B, C out. At least we are getting at least a little bit part of it. But you can also say that, so from column 1 we can take out the A, from column 2 we can take out B, from column 3 we can take out C. You can try, okay? And if you think that way also you are getting the answer, then that is your homework. But what I am going to do is I am going to take out from the row, okay? So from here, the next step would be, you don't have to write anything, just write A, B, C outside, and then this is a minus A, okay, that is a B, and that is C, because A is gone away from here. Now B is going away from here, so you're left with A, then you're left with the minus B, and you're left with the C. Then next C is going away from there, so you're left with A, you're left with B, and you're left with the minus C. Okay. Now from here, the next step, what will be, is to do the operations. So you look, if you add the row 1 and the row 2, if you add these two elements of the first and the second row, if you add these two elements, then you see over here is becoming a 0. Okay, here also 0. Over here only you are getting 2C. So let's do that. So R1 tends to R1 plus R2. That is your next step to do. So let's do it over here. So A, B, C, that is a 0, and here also 0. This is 2C over here. Rest is just copy them. Okay, this is a C, this is A, this is B, and this is a minus C. That's your next step. Okay, from here, one more step. What to do? Expand with this row and this column. So if you were following my videos, in my previous videos and in the previous questions, we were getting a 1 and we were expanding with a 1. Now what we have is a 2C. So we have to use that number also. Okay. So from here the next step would be A, B, C written outside. Now take out that element and write it outside. Say 2C. Write the 2C outside. Put a bracket. Okay. Write the 2C outside. Then do the multiplication. Okay. That 2C you are expanding with that element. So this row and this column is covered. Multiply A into B, AB minus by default, and this is a minus AB. Okay, minus AB. Close the bracket, close this bracket also. ABC, that is a 2C, then this will become a 2AB. Okay, done. This is multiplied actually. So ABC into 4ABC, right? So that is what? 4A square, B square, and C square. So this is proved, right? Proved, and that's the answer. That determinant we started from, and we have proved it. Okay, then let's go on to question number 20. Okay. Let's go ahead and do question number 20. Question number 20. You have to show that the determinant, this marker is not writing, 1 1 1 alpha beta gamma alpha square plus beta gamma beta square plus alpha gamma and gamma square plus alpha beta, okay, is equal to 2 alpha minus beta beta minus gamma and gamma minus alpha okay. Now look, the first thing, this column has all ones, so make any two elements 0. So what do? R1 tends to R1 minus R2, and what is your next operation? R2 tends to R2 minus R3. Okay, so use these two operations and solve that question. Is very easy. So this is a 0, this is a 0, this is a 1. That will give you alpha minus beta. Okay, that will give you beta minus gamma, that is gamma. Next you have alpha square plus beta gamma minus beta square plus alpha gamma. Okay, then the next you have beta square plus alpha gamma minus gamma square plus alpha beta. Okay, check it out. Did we do correctly? This, okay, minus this, then this minus this, R2 minus R3, all correct. Alpha gamma, so if gamma goes common, then you have alpha minus beta, and from here gamma goes common, we have beta minus alpha. So did we do correctly? R2, row 2 minus row 3. Is this correct? Is this correct? Here also gamma minus beta minus alpha we have. Minus gamma. Did we copy correctly? I can see that we have copied correctly over here. All correct, all correct. I don't want to make a mistake. Alpha, beta minus gamma, gamma is gone, beta minus alpha is going over here, and the gamma is gone from here also. The gamma will know alpha. Yes, all correct. Just checking, was checking all correct or not. Alpha, beta. Okay, so this is your next step. Just let me also check whether you can see this properly, because my markers are not actually working properly. So just let me check. Okay, yes, you can see it. Just let's yeah, it's all okay. Okay, I can see that you guys can see nicely. So let's go ahead from here. So this is done. So this element minus this element minus this, everything is done. From here we will continue. Now let's go on. Now you just have to expand with this row and this column, but don't expand now. Let's do a little bit more of the calculation and then expand. Let's take out some common and all. Okay, that I'll write it again in the corner. So that was 2 alpha minus beta, then beta minus gamma, and that is gamma minus alpha. Keep that at the side of your book. That's what you have to prove. You don't have to keep like that. You can just carry on in your notebook. Okay. Then from here, let's do this. So the next part of this determinant is 0, 0, 1. That's alpha minus beta. This is alpha square minus beta square. Look, alpha square minus beta square. Put it together. Alpha square minus beta square. Then plus. Write a plus. Then write a beta. Gamma minus alpha. See, minus alpha gamma. Beta gamma minus alpha gamma is the next one. Now from here, this is beta minus gamma, and from here beta square minus gamma square. This is beta square minus gamma square plus alpha gamma. Okay, alpha gamma minus alpha beta, alpha gamma minus alpha beta. Now rest is all copied, gamma, and this one is gamma square plus alpha beta. So copy it properly. You can put that in a bracket. Since we are putting everything in a bracket, put it in a bracket. Next step from here is 0, 0, 1. That is how it is supposed to be. Now from here, this is a square minus b square formula. That is alpha plus beta, alpha minus beta, then plus. From here, if you take out the gamma common, you can see gamma is common here. So gamma came out, then you have beta minus alpha. Now from here, the next row is beta minus gamma. From here, what's it going to be? Beta plus gamma and beta minus gamma plus. From here, what's common? Alpha is common. Then that is gamma minus beta. Okay, and the rest is just copied. That is a gamma over here, and that is gamma square plus alpha beta. Okay. Now look at this. From here, now we carry on to the next part of this. What is the next part? Look at this. This is alpha beta. Look at this. This is beta minus alpha. So if you take out the negative outside over here and you put the positive, if you just take out the negative, then the sign inside changes. Okay. So the next part of this is going to be 0, 0, 1. This is alpha minus beta. This is beta minus gamma. This is gamma. That is alpha plus beta. That one again is alpha minus beta minus gamma. This is alpha minus beta. See, look, the alpha was a negative, became positive. The beta was a positive, became negative. Okay. Then next is beta plus gamma, beta minus gamma minus the alpha. This became beta minus gamma. Okay. Now next is gamma square. That's not arc, that's gamma square plus gamma beta. You write gamma however you want to write. I write like this. Okay. Next step. Now we are very close to proving it. Okay, you can see you are getting this alpha minus beta over there. Okay, so let's write the next step over here. So what's going to be the next step? The next step is to take out the common. Okay, don't hurry, don't expand it, you'll get confused otherwise. Alpha minus beta over here. From here, alpha minus beta is common. So take it out. Alpha minus beta came out. So inside what we are left with? We are left with alpha plus beta over here. Alpha plus beta over here and a minus gamma over here. Okay. Next, what we have over here? We have is beta minus gamma. Then beta minus gamma is common. See, beta minus gamma is common. Then what you're left with? You're left with beta plus gamma minus alpha. Okay. And the rest is just copied. So gamma square plus alpha beta. Okay. Now from here what to do? From here we expand. There's nothing else to do. It's beta plus gamma minus alpha. That's alpha plus beta minus gamma. I copied all correctly. Let's not rub off that step. Okay. Now next step from here, what's it going to be now? You just expand with this column and this row. Now look, we have a 1 over here. So you don't have to write that 1, just multiply this. This is alpha minus beta into beta minus gamma into beta plus gamma minus alpha. Okay. This is the whole thing is one step. This is just the whole thing is one term. Okay. From here minus, then this into this, that is beta minus gamma over here, then alpha minus beta over here, and next is alpha plus beta minus gamma. So let's just check it out if we multiplied it correctly. Alpha minus beta, beta minus gamma, and this whole thing got multiplied with this. minus sign, then the whole thing, beta, alpha minus beta, and that got multiplied. We all correct? So alpha minus beta, beta minus gamma is common. Take them out. Alpha minus beta and beta minus gamma came out. So what are you left with? You're left with this part, beta plus gamma minus alpha minus, okay, alpha plus beta minus gamma. See, split it into two parts. Now, what do we do from here? All correct? Yeah. Next is do this. Alpha minus beta, beta minus gamma, then open the bracket, beta plus gamma minus alpha minus beta plus gamma. There you go, bracket is open. So what's cancelling out? Only beta and beta getting cancelled out. So what are you getting finally? You're getting alpha minus beta, beta minus gamma. Look over here, this is a gamma plus gamma is 2 gamma, okay, minus alpha, and minus alpha is minus 2 alpha, right? So the next step is take out the 2 common, write it right in front of here, alpha minus beta, beta minus gamma, and gamma minus alpha. So that is the determinant, and that over there and over here is the same thing, okay? So you have proved it. Proudly you can write proved over here. Your work is done, okay? So let's go on to the next question, question number 21. Okay, and try and keep this question last, because question number 21 is not a very small question, it's a long one, okay? So we have to try and split the time up so that we don't get confused and we can understand. So this is question number 21. Okay, a square plus 1, then ab, then ac, then ab, b square plus 1, then it is bc, then ac, bc, and c square plus 1. You can put these terms in bracket, okay? This is equal to a square plus 1, a square, b square plus 1, and again b square, then c square, and c square plus 1. This in turn, this is equal to this, and this is equal to 1 plus a square plus b square plus c square. That's what you have to prove, okay? You have to prove it three parts, okay? First part, what do you have to prove? In the first part, you have to prove this. You have to prove that this determinant 1 is equal to this determinant 2. Case 1, what? Determinant 1 is equal to determinant number 2, and case 2 is determinant 2 is equal to this value, and the case 3, the determinant 1 is directly equal to this value. Directly equal means this is a new question, case 3, okay? This is equal to this, and this is equal to this is already a part of this 2 parts in this question. And the third part that you have to do, depending on the marks, okay, obviously, the third part that you have to do is show this is equal to this. So let's start with case 1. So write case 1, you have to prove that determinant 1 is equal to determinant 2. That is your case 1. Alright. So let's start proving. Write the determinant 1 first. That is a square plus 1 bracket ab, ac, then ab, b square plus 1, bc, ac, bc, and c square plus 1. All copied correctly. A square plus 1, AB, okay, AC, AB, B square plus 1, BC, AC, all copied from the book correctly. Yes. Yes, yes, and yes. Yes, all is correct. What is the next step? Next step, look at your RHS. First, you have to do, what you have to do, you have to look at your RHS, because this is a very confusing question. Okay, if you don't look at your RHS, you won't understand. Look at the first column of your RHS. Look at these two elements. Forget that. Don't get confused. Just look at these two. These are single elements. Look at them. This is a square. This is a square. Do we have an a square over here and an a square over here? No, we don't have. So what to do in order to get an a square? So you multiply this whole column with an a, then you will get a square here and a square here. You multiply this whole column with a b, then you get a b square here and a b square here. That's matching over there. Multiply this column with a c, then you get a c square and a c square here. That's matching over there. Now, since you are multiplying this column with a, this column with a b, and this column with a c, so you also have to divide by 1 by a, 1 by b, and 1 by c, because you cannot multiply something extra. So what are you going to do? The next step is to write an operation, and this is what you have to write. A into c1, comma, b into c2, comma, c into c3. Write this in a box to show that you are multiplying a with the first column, b with the second column, and c with the third column. So let's multiply it here only. I want to multiply it here only. So the next step will be, I will be multiplying and writing the same thing. So instead of doing that, I'm showing it to you over here. So this is going to become a square, and this is also a square. First column multiplied with a square. Second column I am multiplying with a b square, b. So sorry, first column multiplied with an a. So these became a square. Now that's a b square, b over here, and b square over here. This one is c square, and a c over here. Okay. So the next step from here, this is the next step. Okay. From here, this is the next step. Now from there, okay, I also have to divide by 1 by ABC. So divide by 1 by A, 1 by B, 1 by C will give you 1 by ABC. Don't forget that. If you don't divide by 1 by ABC, you're making a mistake. Okay. So that is done. Now next part. Now from here, next part. Take out the A from the first row, B from the second row, C from the third row. Now you say, why sir? Look, if you take out the A from the first row, then you are left with a B square. C is matching you. The A comes out, left with the B square. The A comes out, left with the C square. So take that out. So A, B, C. Over here you don't have to show anything. A, B, C. So now you are left with A square plus 1. Over here you are left with a B square. Over here you are left with a C square. Then over here you have taken out the B. Then you are left with A square. Then you are left with B square plus 1. Then you are left with a C square. Over here you have taken out C. So you are left with A square. You are left with B square. And you are left with C square plus 1. Okay. So these are the values that you are left with. This and this got cancelled out. Now see, you have got your determinant number 2. After this, all you need to do is, that is for that, okay, that equal to is for that. All you need to do is just write this value, that is a square plus 1, a square, b square plus 1, b square, c square, and c square plus 1, okay, which is equal to determinant number 2. So you have proved that determinant 1 is equal to determinant number 2. Put it in a box and put right proof. Okay, because you had started with determinant number 1 at first and you have proved that. Now what is your second case? Your second case is to prove that this determinant number 2 is equal to this value. Okay, so let's start proving that. Let's start proving that this determinant is equal to that value. So what you're going to do, you're going to write second and you're going to write case 2. Case 2. What is case 2? Case 2 is determinant 2 is equal to 1 plus a square plus b square plus c square. You can write this, okay, as a case 2, as a heading. So let's start with that determinant. Write 2, and what are you going to write? A square plus 1, then a square, then b square plus 1, b square, c square, and c square plus 1. What is your next step? Look at your RHS and you will get your next step. Your very simple, a plus 1 plus b square plus c square. 1 plus a square plus b square plus c square, it's coming. So the next step is to write the operation. Column 1 tends to column 1 plus column 2 plus column 3. You have to add the 3 columns and then you're going to get the answer. So what do I do? So that's your operation. Okay, let's write it over here. So let's write it over here. There's no other way, there's no other option to do. You have to write it on top only. I don't have any more space. Okay, so let's add it up. So that is equal to 1 plus a square plus b square plus c square. Again over here same thing, 1 plus a square plus b square plus c square. Okay, marker is not writing. Okay, let's try this. So again 1 plus a square plus b square plus c square. Rest is just copied. So let's copy them. What is copied? This is b square. This is b square. This is b square plus 1. This is again b square. Okay. This is c square. This is c square. And this is c square plus 1. Everything else is copied. Now what is your next step? Just take that out. Common from the first column. Okay. Take out 1 plus a square plus b square common from the first column and solve the question quickly. 1 plus a square plus b square plus c square came out common. So you're left with 1, 1, 1. Then over here b square, over here b square plus 1. Over here b square, over here c square, here c square and c square plus 1. That is your next step. Okay. Now from here what you need to do? What you need to do is very, very simple. From here just make any two ones, make them 0. So your next operation that you're going to apply is going to be this. So R1 tends to R1 minus R2. Okay. And R2 tends to R2 minus R3. When you perform these two operations, you will start saying that your answer is slowly coming out. So let's start doing that. Let's start doing these two operations. Let's start finding the answer. Okay. So what is your next step now? To expand 1 plus a square plus b square plus c square is come out. Now 0, 0, 1 over here. I know you cannot see because it's a little light. 0, 0, 1. B square minus b square minus 1, right? See, minus 1. B square minus b square gone away and a minus sign because there was a minus sign outside the bracket. This minus this is 0. Now this minus this, b square plus 1 minus b square. B square minus b square gone. This is just a plus 1. Okay, that is this minus this, you're getting a minus 1. Then rest is just copied, b square c square plus 1. So look very carefully, what are you getting? 1 plus a square plus b square plus c square, you are getting this. Now when you multiply, what are you getting? So cover this column and cover this row and multiply this into this. Minus 1 into minus 1 is 1, minus 0. So finally what is your answer coming? You got your answer and this is your answer. Yeah? So that's your answer. That determinant number 2 is equal to this. So proved. Right, proved over here and be happy that you have proved it. Now, what is the case 3? This is case 3. Look. Case 3 is going to be determinant 1 is equal to 1 plus a square plus b square plus c square. So how are you going to do? Simple. Just follow the steps I just did. How? You're going to take the determinant 1, first prove it like this to determinant number 2. But don't write that this is equal to this determinant 2. you're doing an absolutely new question. Okay, it's a new question. You're doing a different question thing. So case 3 is a different question. Okay, this determinant 1 you have to first prove to determinant number 2. Now from there you have to repeat the same steps and get this final answer. Determinant 1 is equal to this value. So that for you, I'm going to give it to you for homework, and we are done with these 3 questions. So let me just take them. Question number 19 is done, question number 20 is done, and question number 21 is done. So in the next video I'm going to do question number 22, 23 and 24. They are very long questions, so I'm going to do them, and slowly we are going on to the difficult ones, and then we'll go on to Kramer's rule and all that. There are many things to learn from this chapter. We'll finish it very soon. Okay, that's it for today. Take as much help as possible from my channel and your channel, Math is Possible. See you in the next video.